Sonic, the heart of your system.
What is up, guys? This is Luke Hill for Kit Guru, and this is the ASRock X570 Taichi. So this is ASRock's £300 premium X570 offering. It features a host of RGB features. You've got a strong 14-phase power delivery solution, and then you've got triple M.2 connectors. So if there's some of the features that take your fancy, then do continue watching. Let's dive deeper. So the first thing we'll notice with the ASRock X570 Taichi is the overall styling. So you've got a primarily black styling, you also have hints of grey, and then ASRock's Taichi cog and gear type mechanism or print is present there, as we've seen on previous Taichi boards. ASRock's pretty smart here because some of the screws are actually integrated with the artwork, so I quite like that. It's a nice little touch. And then the other little touch that I like are the subtle gold accents you see on top of the chipset heatsink and also from some of the gold capacitors. So on the lower area of the motherboard next to the expansion slot, and obviously covering the M.2 connectors, we've got an aluminium shroud, and I'll come back to that in more detail later. So when we're focusing on the RGB zones, we have 3 discrete zones used on the motherboard. So you've got the rear I/O shroud has an RGB zone, you've got the chipset heatsink, and then you've also got this edge lighting zone on the right side of the motherboard, so near the 24-pin area, and that goes down the entire right edge. And that looks quite nice, the edge one, to be honest. They all look pretty good, so the intensity is pretty strong. The brightness, I like that. The color contrast, I like that too. You get good control within ASRock's UEFI and also the OS software, so the control in the UEFI is a strong point if you don't want to install any Windows software. Good features there. I like the RGB on this board. So in terms of memory, we have the usual bank of 4 DDR4 DIMM slots, and this will take up to 128 gigabytes of memory. Now, ASRock quotes support on its website for 46, 66 megahertz or above via overclocking. Of course, that depends on the strength of your CPU's IMC. However, within the QVL, we have seen that ASRock has suggested 4600 megahertz from one G-Skill kit. Patriot 4400 megahertz kit that can only run at 4000. ASRock's QVL is a bit silly, to be honest. It doesn't make all that much sense, so I'd take it with a rather large grain of salt. So continuing our focus on this top area, we have a single outwards facing USB 5 gigabits per second port, and this is the only one on the motherboard, so slight disappointment there if you need more than one. We've got a bunch of fan headers within reach of the AM4 CPU socket, and all of these are 4-pin and feature really good control through the OS software and through the UEFI. We don't have any dual BIOS redundancy or any switches, so that's a little bit disappointing, although ASRock does include a 256 megabit chip, so large enough for future BIOS revisions, we'd hope. You don't get any onboard voltage monitoring points either, and that's another slight disappointment, although perhaps more understandable at this price point. It's good for checking, but maybe not all that useful to most people. So one of ASRock's smarter positioning moves is putting a bundle of headers for use with the AMD Wraith cooler that is provided with the Ryzen 7 or the Ryzen 9 chip. So of course this needs an RGB connection, a USB connection, and also a fan connection. So ASRock puts 3 of these headers right next to the AM4 CPU sockets, so you don't have to bundle them up of the motherboard, don't have to bundle the USB header down to the bottom, so through your motherboard tray. And also you can position the AMD label in the correct orientation while still hiding your cables. I like this. The USB header is only half height, so you only get obviously one bank of connections, but that's perfectly fine for CPU coolers. Smart move. However, this RGB connector does take away from the top positioning, so if you've got a strip in the top of your case, then you might have to look for an extension. But overall, good feature, I like that. So looking at the SATA ports, ASRock is very healthy with what it offers here. So we get 8 SATA 6 gigabits per second connections. This is good to see because obviously some other boards in the higher end we've seen have had 4, which is inadequate. 8 is probably more than enough for most people. And these don't share bandwidth with the M.2 connectors, so you can use all 8 of these even whilst you're using the M.2 connectors, and that's a really positive feature, especially if you're an absolute storage nut. So arguably the stupidest, quite frankly, design decision on this motherboard is the internal USB-C header positioning. So as you can see, it doesn't take a genius to figure out that this is going to be blocked by any graphics card that's longer than about 9 inches long, which is, let me think, pretty much every high-end graphics card that X570 buyers would be looking at, unless you go in mini ITX, at which point you wouldn't be buying an ATX motherboard. So you stick a graphics card in, your USB Type-C header is blocked and you cannot use it. It's as simple as that. Now, we've seen reports that if you reach out to ASRock, that you can get a right-angled cable, which is, I guess, kind of a cumbersome way of fixing an issue that shouldn't be there in the first place. And ASRock has confirmed to us that new batches of this motherboard will actually ship with an adjusted USB Type-C header position. So that's good that the issue has been acknowledged and it has been supported by ASRock, but how on earth this passed quality control in the first place, I do not know. This is a really, really poor move. So along the bottom edge, we have more headers. We've got another 2 USB 2 headers. So this is good for using with an AIO cooler or the like. So that takes us up to a total of 2 full-size USB 2 headers and then the 1 half-height header near the AM4 socket. We get another 4-pin fan header, and we get a Thunderbolt add-in card header and 2 of the 3 RGB LED headers on the board. So one of these is addressable, one of these is standard RGB. One of my favorite features on this board, which I really like to see on premium offerings, are the onboard power, reset, clear CMOS buttons. They're in a good location because they're unlikely to be blocked by a graphics card or the likes. And I also like the positioning of the Doctor Debug LED. This is another feature I really like. If you're troubleshooting and you're having problems, just being able to get that code from the LED is really, really useful. So in terms of expansion slots, this is the usual setup that we typically see from X570 motherboards. So you've got 3 full-length PCIe slots. Of course, 2 of these, the top 2, can be used from lanes from a CPU, so X16 and X0 or X8, X8, and that's of course Gen 4 if you're using a Ryzen 3000 CPU. SLI and Crossfire are supported if you still use those these days. The bottom full-length slot is 4 lanes of PCIe Gen 4 bandwidth from the X570 chipset. However, this bandwidth is shared with one of your M.2 connectors, so you'll have to take your pick on which one you prefer to use. I like that ASRock includes 2 X1 length Gen 4 slots, and I like that they're open-ended because this means you can install a physically larger card. Oh wait, that shroud is blocking it, so the fact that these are open-ended is kind of pointless really unless you're going to pull out your Dremel. You know, A for effort. ASRock's Purity Sound audio system is built around the common and popular and very well used Realtek ALC 1220 audio codec. For an operation amplifier you get a TI NE5532 and then you get a bunch of Nichicon fine gold audio capacitors. So moving around to the rear I/O area, we see that ASRock has gone completely all out when it comes to USB 3.05 gigabits per second connections. So we get a total of 6 of these, 2 of which support ASRock's higher powered mode, and 1 of which is reserved for BIOS flash duties, which is a really good feature if you're buying this motherboard with a future CPU. We get 2 10 gigabits per second USB 3.2 Gen 2 ports, 1 in Type A form and 1 in Type C form. We also get gigabit Ethernet from an Intel i211AT adapter, and you get 2.4 gigabits per second capable Wi-Fi 6 connection, also from an Intel adapter. Audio is the usual affair from the Realtek chipset, and you get an onboard clear CMOS button, which I love to see, and it's positioned so you're not going to accidentally hit this. You also get HDMI 2.0 with HDCP 2.2 support, and that's really good if you plan to use this motherboard with an APU. Probably unlikely at this point in time, but if more powerful APUs come on the AM4 platform in the future, this could be a really useful feature actually. So the biggest annoyance from the rear I/O selection is the lack of 2.5 gigabit Ethernet. At a price point of this, then Asus is supplying 2.5 gigabit Ethernet with its X570E competitor. So the fact that ASRock doesn't include it, it might not be a big deal to most people. It probably isn't to most people, but it's slightly disappointing to see ASRock out-featured by Asus on this one specific port. And of course, when it comes to rear I/O, the integrated I/O shield, great feature, love to see that, adds a premium touch. And then you've got the X570 Taichi and the branded plastic I/O cover. So coming back to this shroud, it's actually a plate of metal that is held in place by 3 T8 Torx screws. So very uncommon screws, but thankfully ASRock includes a tool so that you can take these off quite easily. So once you undo the 3 Torx screws, you actually get access to the 3 M.2 connectors and there's 3 strips of thermal pad, so you can cool the M.2 devices, and then there's another thermal pad cooling the chipset heatsink. Now, this is really cumbersome, to be honest. It's good in theory because you get a lot of metal mass and surface area to be able to cool your M.2 devices, so that's a really strong positive. However, it's very frustrating because you have to remove 3 screws in this entire cover just to be able to install an M.2 device. Now when you're first building the system, that's not a problem, but if you've got a fully built system, you see a good deal on an M.2 SSD and you want to upgrade, you have to take out your graphics card, You have to remove the screws, you have to remove the cover, you have to put your new SSD in, you have to replace the cover and put your graphics card back in. That's not the case with other boards. You just take off the M.2 heatsink, slot in your M.2 device, and put the M.2 heatsink back on. So very time consuming, cumbersome approach compared to the alternative solutions. However, the improved cooling ability may be worth that, depending upon your preference. So one of the other features of this shroud is to integrate some of the LED lighting around the chipset heatsink, and it also is used to shroud the chipset heatsink fan. So the chipset fan is actually a 40mm unit, and ASRock makes an effort to use proper blades on this fan, but the hub is such a large proportion of the overall fan area, then you're still getting pretty small blades, which are going to result in high RPM. And to be honest, high RPM is exactly what we saw during our testing, so it doesn't really want to operate below about 3000 or so RPM, even when you're in the UEFI. You can force it below that level, but the chipset heatsink is just not very well designed, to be honest. That lump of metal is pretty small. The fan doesn't actually sit directly above the silicon position of the chipset, so that loses the effectiveness somewhat of the coolant air that is being blown over the heatsink. And of course the position of the fan is directly beneath where the graphics card is going to be. So if you've got an open air cooler, which most graphics cards these days do, especially aftermarket ones, you're going to be sucking in hot air from a GPU, which is not going to be any good for cooling performance. So a little bit disappointed with this design here from ASRock, and as our testing will show, the performance isn't really great. So as far as M.2 SSDs go, we've got 3 connectors, 2 of which support PCIe and SATA devices, with the other one supporting PCIe devices only. One of these supports drives up to 110mm in length, and the top slot is from the X570 or the AM4 CPU, and the bottom 2 slots, they're from the X570 chipset. Now, as we mentioned earlier, the bottom slot shares this bandwidth with the bottom PCIe slot, so take your pick on which one you'd prefer to use. Looking at ASRock's VRM, they're using a 14-phase system, which is split as 12 plus 2, so 12 for the CPU, 2 for the SoC. Using the Intersil ISL 69147 PWM controller with a total of 7 ISL 6617A phase doublers. This is actually a 6x2 plus 1x2 system. And there's nothing all that wrong with that, to be honest. I mean, it's quite common, with the exception of Gigabyte, which is using a higher phase PWM. ASRock is using Vishay SIC 634 power stages here, so these are 50 amp continuous rated. When they're packed in this solution, they're probably not going to do 50 amps continuously, but to be fair, they're not going to be asked to do 50 amps continuously on AM4. In theory, and according to the datasheet, you can get 10% higher current delivery from these, so 55 amps for 10 millisecond periods, but that would just be good for burst load situations. You're probably not going to need it because 12 phases is complete overkill for current and even the 16-core AM4 CPU. So the VRM heatsink itself is okay. I'm not going to say any more than okay. To be fair, it's okay actually. It's not too bad. You get a big lump of metal for each of the heat sinks, and these are connected via heat pipe, which is good, so they can share the load between them. There's no real effort to actually make an effective heat sink, so there's no increase in surface area via fins, but the fact that it is a big lump of metal will give you a lot of thermal capacitance, so that should help to mitigate spikes in temperature and quick rises in temperature from short loads. Obviously, you could have the alternative effect if you have a long sustained load and try and reduce that temperature by removing the load. But overall, they're not too bad. And when you're using the pretty efficient power delivery system beneath them with 12 phases allocated to the CPU, I think these are going to do a perfectly adequate job. Now the backplate looks promising. It's a metal backplate, so a thin piece of metal. It doesn't make any direct thermal contact with the PCB. So unlike what we saw from the Gigabyte X570 Aorus Master, you're not going to get any cooling benefits here. And that's a bit disappointing because ASRock missed a trick there, because this could have been a perfectly adequate place to dump any heat coming from the PCB areas where the MOSFETs are mounted. So a little bit frustrating there, but you know, that's what it is. You get a mount for the edge RGB lighting system, and then more importantly, this is just going to aid your structural rigidity of your motherboard, especially if you're hanging heavy graphics cards or large CPU coolers off the front side. So if you want to see more details on the UEFI and the software that ASRock includes with the X570 Taichi, make sure you head on over to the Kikaroo website where we've got the screenshots and written analysis there. To test ASRock's X570 Taichi, we're using the latest BIOS revision, and that's P2.00. That uses the AMD ABB AGESA version, so not the latest ABB-A, which hasn't been officially released yet. So our test system consists of the AMD Ryzen 9 3900X 12-core CPU, cooled by a Corsair H100X 240mm AIO at full 1700 RPM fan speed. Memory comes in the form of a 2x8GB 3200MHz C14 G-Skill kit, which uses Samsung B-Die ICs. Pixel pushing duties are handled by the beastly Gigabyte Aorus RTX 2080 Ti Gaming OC with a custom fan speed curve to minimize GPU boost clock reductions. For the SSD, we use a WD Black NVMe drive for the OS, Gigabyte's Phison-powered PCIe Gen 4 SSD for speed testing, and a Crucial MX300 for game storage. Power is handled by the absolutely overkill and highly efficient Seasonic Prime Titanium 1000W power supply, and we're using Windows 10 1903 with the latest updates and AMD power profiles. Clock speeds for the ASRock board tend to be slightly higher than competitors by about 100 to 200 MHz throughout our testing, and that's for all core sustained clocks. This is because ASRock is pretty aggressive when pushing the voltages, and obviously this has a downside for power consumption and also temperatures, but we'll get into that in more detail later. Cinebench R20 shows ASRock's X570 Taichi top in the multi-core chart thanks to its higher clock speed via more aggressive voltages. The performance increase over the next fastest X570 board we have tested is a solid 2%. According to our logs, the Ryzen 9 3900X sat nicely at 4125 MHz throughout this test, with ASRock's board pumping over 1.35 volts through the chip. Single-threaded performance isn't as fast as Gigabyte's X570 Aorus Master, but it is still solid at just over 500 points. Our logs showed a maximum single-core boost of 4575 MHz for a single 2-second data point. 4425 to 4475 MHz seemed to be the more consistently achieved single-core boost clock. Blender completes a couple of seconds quicker on the ASRock board thanks to its more aggressive voltage setting and CPU clock speed. This run also demands more power from the system than MSI and Gigabyte's competitors, however, but that could be a worthwhile trade-off in your use case. Memory bandwidth is where we'd expect it for 3200MHz CL14 DDR4 in dual channel configuration. The same can be said for the latency performance, which came in a touch slower than our X570 leader. ASRock continues to show similar memory performance to the Gigabyte X570 Aorus Master, with the 35 GB per second result in Cysoft Sandra. Surprisingly, given its higher boost clock frequencies through more aggressive CPU voltage, the X570 Taichi was a little slower than the rest in 3D Mark Time Spy. The defeat is very narrow, however. Clearly, the 3D Mark hiccup does not transfer into real-world gaming performance, with ASRock's X570 solution sitting close to the performance of MSI's class-leading alternative. Shadow of the Tomb Raider shows another solid gaming result for the X570 Taichi, with its average performance sitting between Gigabyte and MSI. With that said, frame consistency wasn't quite as good as the two competitors, with a 95% FPS number from ASRock's board scoring a little lower throughout our testing. The difference is very, very minor, however. No cause for concerns from the X570 Taichi's M.2 speed, with our Aorus PCIe Gen 4 SSD closing in on 5GB per second. Cooling performance from ASRock's Metal Shroud proved adequate, with the Aorus SSD sitting comfortably around 60 degrees Celsius for our short duration write load. Read and write speeds in the 900 megabytes per second range show that ASRock's USB 3.2 Gen 2 10 gigabits per second deployment is working as intended. Rightmark Audio Analyzer rates ASRock's ALC 1220 based Purity Sound system as very good overall, with several of the categories rated excellent. Overclocking was particularly easy with the X570 Taichi, thanks in large to ASRock's well laid out UEFI, clear load line calibration settings, and seemingly accurate software based voltage readings. We were able to hit a stable frequency of 4250 MHz using 1.35 volts as set in the UEFI. We applied the level 2 load line calibration setting, as this resulted in a load voltage of 1.36 volts according to CPU-Z and 1.35 volts according to Ryzen Master. Level 1 LLC pushed voltage a little higher than we'd have liked, with its 26 mV overshoot, so we decided not to go for this. Much of ASRock's power-related sensor data, as fed through to monitoring tools including Ryzen Master, is simply incorrect. As such, we used our power reading from the wall to interpret that the Ryzen 9 3900X was indeed being fed with the voltage of around 1.35 volts that we'd requested. With the Ryzen 9 3900X CPU's speed boosted to 4.25 GHz by ASRock's X570 Taichi motherboard, Cinebench R20 multi-core performance increased by 251 points. This 3.5% gain is quite slim for an overclocked result, but that is due to the aggressive voltage and clock speeds that ASRock's board permits at stock. Unsurprisingly, given the aggressive voltages that ASRock applies to our Ryzen 9 3900X under stock conditions, power draws around 30 to 40 watts higher than what we'd expect from the 12-core Ryzen chip. That's not ideal as it translates into extra load on the VRM components and extra stress on the thermal solutions, though it does come with a performance boost in multi-threaded workloads. This was not related to ASRock sneakily applying Precision Boost Overdrive, as we disabled this manually within the UEFI. Incorrect power and TDC data will be fed through to Ryzen Master, and one would assume that this data is also being input to the Precision Boost 2 algorithm. In turn, there was no power or thermal current throttling according to Ryzen Master, and the CPU was glued to 100% electrical current input of 142 amps. This looks to be the reason for ASRock's more aggressive CPU voltage and higher clock speeds. Our 1.35 volt overclocked voltage actually managed to maintain roughly the same power consumption despite running 125 MHz higher under all core conditions. Clearly, the stock settings are not ideal for users who care about how much power their system draws, especially if that heat is then dumped inside a non-air conditioned room, like in the UK. The Ryzen 9 3900X registered more than 80 degrees Celsius under our H100X at stock settings. ASRock's aggressive stock voltage and frequency is to thank for that. Despite ASRock's MOSFET heatsink being more focused on looks than efficient cooling performance, the VRM temperatures were perfectly reasonable according to data from VR Loop 1 sensor. Overclocking pushed temperatures higher as the frequency was increased, but ASRock's voltage accuracy helped to keep our Ryzen 9 part away from the 95 degrees Celsius limit. VRM temperatures were still perfectly good when the CPU was overclocked. One temperature that isn't plotted in the chart but is worthy of reference is the X570 chipset. ASRock's cooling system for this piece of silicon is not particularly high performance, and that really showed throughout the testing, with temperatures regularly drifting past 70 degrees Celsius despite the 40mm fan spinning at more than 4,000 RPM on our open-air test bench. This is worth bearing in mind when you are plotting fan speed curves through ASRock's excellent UEFI and software-based tools. So overall, the ASRock X570 Taichi has a good feature set. It has a really smart RGB LED solution, which I particularly like. It's got plenty of lighting zones and pretty good control through software, especially through the UEFI. You get a 14-phase power delivery solution, which is good to see. It worked well in our testing and stayed perfectly cool with the 12-core chip, even when overclocked. You get triple M.2 connectors, that's a good thing, and you get plenty of high-speed USB on the back panel. Another area that I was particularly fond of were the onboard power reset, clear CMOS, and also the debug LED. That's really good for testing and for troubleshooting. It's a feature that ASRock offers when some of its competitors don't at this price point, so it's one of those minor points that I really like to see. Now, the key point for ASRock's X570 Taichi, in my opinion, is the very strong performance that it offers out of the box. Now, of course, this comes through pushing additional voltage through the CPU so that it can boost to a higher all-core frequency, and that comes at the expense of power draw and also temperatures. So temperatures were typically a little bit higher than we saw on competing models, and the power consumption was clearly higher. So, is that free performance? Well, no, clearly not. You're pushing your chip harder. It's kind of like PBO-type scenarios. And if you were overclocking, you would just ignore that anyway. It doesn't come for free, but it could be useful to you if you just want to run at stock conditions without messing around with the BIOS. The UEFI is the same as we always see from ASRock. It's well laid out, it's easy to use, it's nothing too fancy, it just works. There's no stability concerns. And the RGB tool within the UEFI is really good, especially if you don't want to include the OS software. Now, there are some negatives that we've already highlighted. Most notably, the internal USB-C header positioning is really silly. That's a bad move, but you can contact ASRock so they can help you with that. It shouldn't have been there in the first place, to be honest, though. The chipset fan is quite loud and quite obnoxious, especially when it's spinning at over 4,000 RPM and still registering like 70 degrees temperature throughout our basic testing. So that's not good to see. The M.2 shroud it's a good feature because it gives you a lot of surface area to cool your M.2 devices. However, it is slightly frustrating that you need to take a lot longer to install a new M.2 SSD, especially if your system's already built. You basically have to disassemble a lot of it. So that's quite frustrating. It depends on your preference. Obviously, the other point that you can't use the heatsink that is supplied with your M.2 device because it just won't physically fit. That is also disappointing, especially if you paid money for a well-engineered heatsink from the likes of Aorus or Corsair. And there are more minor points that some of the competitors at this price point offer. So Gigabyte has an option with dual BIOS, which, given the frequency of BIOS updates on the X570 platform at the moment, is quite a useful feature, I think. Asus also provides its competitor with 2.5 gigabit Ethernet, so that could be one of the features that you think is useful for you going forward in the future. However, ASRock has some of its own features which compete with those boards very, very nicely. The VRM solution is very good. The cooling worked well. The performance is solid. So I think for £300, this is a good offering if the features tick your box. However, there are some negatives which may turn you off or slightly depress the feeling of a premium offering, and I think ASRock needs to address some of these. Overall, a good performer, but it depends on what you're after. So I've been Luke Hill for Kit Guru. Thank you for watching our review of the ASRock X570 Taichi motherboard. Let us know in the comments what you think. Are you happy with some of the mistakes that ASRock made? Are you happy with the features overall? Do you think some of the issues are less of a problem than others? If you like this video, make sure you give us a like and hit that subscribe button. Head on over to the Kit Guru website where you can see the full written review with more detail and more technical analysis. That's really useful. And then also, if you like to support us, then head on over to our Patreon page and take a look at our merch store. I'll see you in the next one.